Coming to the second question, root 3 plus root 5. We need to prove root 3 plus root 5 as an irrational number, right? First, what is the first step? Root 3 plus root 5. We will assume, let us assume root 3 plus root 5 is a rational number, right? If it is a rational number, it is in the form of a by b comma where a comma b are co-prime integers and b should not be equal to 0, and squaring on both sides, right? If you do squaring on both sides, you will get like this, and now if it is in the form of a plus b whole square, right? We know a plus b whole square equal to a square plus 2ab plus b square. Right now, a square plus b square plus 2ab, that will be equal to, here also we have square b square, right? It can be 3 plus 5 plus 2 root 50 equal to a square by b square. Right now, 8 plus 2 root 15 equal to a square by b square. Right, 2 root 15 equal to a square by b square minus 8, right? Now 2 root 15 equal to a square minus 8b square by b square, right? If you take LCM for the denominators here, right, root 15 equal to a square minus 8b square. What 2 is doing here? 2 is multiplying, right? If it transpose to this side, that will divide whatever the numerator is there, right? Clear? Now here in the right hand side we have a square minus 8b square by 2b square. In the left hand side we have root 15, right? Right. For any value of a comma b, a square minus 8b square by 2b square is rational. If it is rational, if a square minus 8b square by 2b square is rational, left hand side will also become root 15 is also rational, right? Right, but we know already root 15 is irrational, right? This contradicts to the fact that root 15 is an irrational, right? Why this contradiction has a reason? This contradiction has a reason due to our assumption, right? Right, that means our assumption is, because we have assumed that root 3 plus root 5 as rational number, we got this contradiction, right? Therefore our assumption is wrong. Then what is right? Root 3 plus root 5 is irrational number. Irrational number.